This is Geometry, Unit 7, the Quiz 1 review. This is worksheet number 2. We're going to draw a right triangle. With sides M and N and hypotenuse of K, where the hypotenuse is always across from the 90 degree, so that would be K. Your two other sides would be called legs of a right triangle. To write a formula that represents the relationship between these, we know that the hypotenuse squared has to equal the sum of the legs, the square, to square the sides and add them together. We're going to solve for x. We recognize this is a right triangle. It does not, there's no hint here that this is a 30, 60, 90. In fact, from the short leg to the long leg, it doesn't show that property. So the best I can do is say that the hypotenuse squared equals leg squared plus leg squared. Across from the 90 is your hypotenuse. The other two are your legs. So we're going to say that x squared equals 9 squared plus 12 squared. 81 plus 144. 225. And when you take the square root of 225, we get 15. So that's what x would equal. In our situation here, the short leg times 2 is not what the hypotenuse is, so we know this is not a 30, 60, 90. Don't just assume it and do the rules for 30, 60, 90. So we have to use the Pythagorean theorem. Across from the 90 is your hypotenuse. The other two sides that make up the box are the legs. So 34 squared is going to equal 16 squared plus x squared. X is one of the legs in this case, so that stays on the other side of the equal sign than the hypotenuse. 16 squared is 256. Subtract that across. And we get 30. So that's the leg of the right triangle. Across from the 90 is the hypotenuse. The other two sides are called the legs of the right triangle. When you square 50, subtract the 100. When we take the square root, that's what x would be, but 2400 is going to clearly break down to be 24 times 100. That might be one way to do it. You know that the square root of 100 is 10. 24 can be broken down into 4 times 6. So now you're going to pull out that 2. So now we have 20 root 6. we're going to find the area of an isosceles triangle. We have side lengths of 17 and a base of 18. So if the two sides that are the same are 17 and the base is 18, to figure out what the area of a triangle is, we need to know what the height of the triangle is. So I'm just going to use the one side of this triangle. When we look at this triangle, if all the sides were exactly the same, then I know it would be a 60, 60, 60. But all the sides are not the same. So the best that I can do is to know that across from the 90 is the 17. Because this point is equal distance to the end point, I know that it bisects this opposite side, so this is 9. And we can calculate the hypotenuse squared equals the leg squared plus the other leg, we'll call it h for the height. So 17 squared is 289. When we subtract 81, we get 208. We'll take the square root of 208. 208 can be broken down into 16 times 13. You might break it down into different increments, but eventually you should get 4 square root 13. That's what h, that's the height of the triangle. So now we're dealing with our right triangle that has 17, a height of 4 root 13, and a base of 18. So to figure out the area, that's half the base times the height. So we could do that. We could take half of 18. So that's going to become 36 square root 13. And our units are in feet. It's area, so it's feet squared. A shipping dock has a mobile ramp that is used to help load and unload cargo from the trucks. The ramp is 125 inches long and has a base that's 120 inches long. What is the height of the ramp? So we're trying to figure out h. Again, this is a right triangle. We already know two sides, so we can use Pythagorean theorem or even perhaps a Pythagorean triple to help us calculate this. That's 125. That's 120. And my height is going to be the shortest. So what I recognize right now is that 5 goes into all of these. So I'm getting the number 25, getting the number 24, and my unknown value. Well, if I look at my Pythagorean triples, I see 7, 24, and 25 is a Pythagorean triple. So I'm going to take that 7, multiply it by what I was dividing by, and I know my missing side is going to be 36. So we say, 35 inches. So I used a Pythagorean triple to help me solve for that. You might use a Pythagorean theorem. You would get the same result. We're going to find the area of the triangle. We're going to round our answers to the nearest hundredth. So we remember that the area is base times height, so I don't know this side. I don't recognize this as being a Pythagorean triple. So I'm going to say across from the 90 is the hypotenuse. The other two sides are the legs. So we have 10 squared equals 5 squared plus x squared. 100 equals 25 plus x squared. By subtracting that across, we get 75 equals x squared. We can take the square root of 75, which is 25 times 3, which is 5 square root 3. That's what the height is. I'm sorry, that's what this base is. So now to calculate the area, it's the base times the height. So this is going to come out to be half of 25 root 3 divided by 2. So I know that we're going to take half. Using our calculator, we come up with 43.30, and dividing that in half, we get an area of 21.65, and that would be units squared. On this next triangle, if we're finding the area of the triangle, we need to know the base and the height. Well, right now I don't know what the height is. The height clearly is not 55. The height has to be perpendicular to the base. So I have to use this right triangle. Remember, we've learned that if a point is equal distance to the endpoints of a segment, then it has to be on the perpendicular bisector. So I know that this has to be 44, and this would be 44. It hits it right at the midpoint. So my hypotenuse is 55. Well, I just recognized something. If we use our unknown, our 44, and our 55, what number goes into 44 and 55? We're going to get 4 and we're going to get 5. So what's the Pythagorean triple that deals with something 4, 5? Well, of course, that is 3, 4, 5. So we're going to take our 3, multiply that by 11 to get 33. So I now know my height is 33. So to calculate the area, the base is 88. The height is 33. I can take half of either one of those. I can multiply those together and then take half of it. But I'm going to take half of the 88. And then I'll multiply those together, and I get an area of 1,452. Looks like the units are yards, and it's of course squared. Here we have a rectangle with QR of 8 and SQ of 10. What is the value of Y? Well, if this is a rectangle, then I know opposite sides are congruent. So now I have this right triangle. It's a rectangle, so I know we have a 90-degree angle. There's your hypotenuse. These are the legs. We're trying to find the value of Y. Well, I'm going to look at this as a Pythagorean triple. You can use Pythagorean theorem just fine. What number goes into 8 and 10? I get the numbers 4 and 5. So of course, hopefully you're beginning to recognize that 3, 4, 5 Pythagorean triple. So because 3 was our missing side, and we're going to multiply that by 2 to get it twice as big. So that has to be 6. Working on the back side, we're going to look at the Pythagorean triple and try to use that to solve for a missing side. We have the number 50 and 120, and we're looking for the hypotenuse. Some Pythagorean triples that we typically would be looking for would be the numbers 3, 4, 5. That's a common one. 5, 12, 13. 8, 15, 17. And 7, 24, 25. So we're going to take what we have here. We can divide it by the largest number that can go into both of them. I see they both have zeros. So we would get 5, 12, and another number. The other number, trying to think of those Pythagorean triples, of course, the 5, 12, 13 would be the missing number. So we need to take that 13 and multiply it by our unknown to give us 130. So that would be 130 centimeters. Pythagorean theorem, hypotenuse squared equals leg squared plus leg squared, would be a way to solve this and not get strapped down with Pythagorean triple. Pythagorean triple can be used for a great shortcut. If you notice, it's a lot less work. So here we're looking for a leg. So we have 28. We're missing a leg, and we have the hypotenuse. So the number that can go into all of these, 4, would give us 7, and 25. So if it fails and you got to do Pythagorean theorem with smaller numbers, that would be an option. But hopefully, this is a tougher one for sure. 7, 24, 25 is our other Pythagorean triple that we could use. Now we would take our 24, times it by the 4 to get 96. So we know that this side is 96 inches. Okay, looking at the triangle inequality, we're going looking for a right triangle. We know that the longest side has to be equal to the sum of the squares of the other two sides. For an acute angle, the longest side would be less than. The obtuse triangle, the longest side would be greater than. So to use that concept, we're first going to test to see if this makes a triangle. And I see that this is 119. And 119 is greater than 89. So first of all, we're testing with the smallest sides to be sure that it's bigger than the largest, just to verify if it is truly a triangle. So yes, this is a triangle. Next, we're going to take the largest side. We're going to compare it, so I like to use the circle to represent that. 39 squared and 80 squared. So we take 89 squared, we get 7,921. We're going to compare that with 1,521, 6,400. Add those together, and this comes out to be 7,921 also. So because they equal each other, this is going to be a right triangle. Using our rule from up top, that if the largest side equals the sum of the other two sides squared, then it's going to be a right triangle. Here we take the two smaller sides, so we get 31. We notice that that is bigger than the largest side. All that tells us is that it truly makes a triangle. Now, to figure out if it's a right or cubed or obtuse triangle, we have to go back to the largest side cubed or squared and compare that with the smallest side squared and the medium side squared. So 23 squared is 529, and we're going to compare that with 11 squared and 20 squared. So 529 and 521. 529 is truly bigger, so since the largest side squared is larger, we know that this is an obtuse triangle. We'll come here to our last one. We notice that the two small sides add up to be greater, over here, the two small sides add up to be greater than the largest. 14 is of course larger than 12, so 8 and 2 make 20. 20.4 is of course larger than 14.4. So 14.4 squared compared to 8.2 squared and 12.2 squared. So this is going to come out to be 200.7.36, 67.24, and 148.84. So when we compare this together, we see that this comes out to be 216.08. The a squared b squared is greater than the longest side squared, which tells us this has to be an acute triangle. Number 18 and 19, we're looking for the special right triangle rules. In other words, what are the formulas? This is a 45, 45, 90 triangle, so we know the two legs are the same length. And the hypotenuse is the leg times root 2. The formula we use for a 45, 45, 90 triangle is hypotenuse equals leg root 2. So regardless of which bit of information you have, you can solve for the unknown. The 30, 60, 90, the shortest leg would be across from the 30. The longest leg is going to be across from the 60, and of course the hypotenuse is going to be across from the 90. So we'd get x, 2x, and x root 3. Those are the notes that come along with the rules for a 30, 60, 90 triangle. The formulas we use for that is that the hypotenuse is twice as big as a short leg. So it's the short leg times 2. The long leg is root 3 times as big as a short leg. So short leg, or short, root 3. So regardless of your unknown, you can solve for the missing side. Notice you always have to go through the shortest. It's all related to the shortest side. Find the missing side lengths. Leave in radical form. Radical form means that the answer is going to have a radical in it. Or at least it's going to be a perfect square. That would work also. But it's going to have a radical in it. The answer would be like 2 root 6. That could be a final answer. So here we're looking at 21. 45, 45, 90. So in a 45, 45, 90, we know that the legs have to be the same length. So that makes, well, it's not x. But the legs are going to be the same length, which is 11. X is the hypotenuse. So the hypotenuse equals this leg times root 2. So this hypotenuse value, which we'll call x, is going to equal 11 root 2. Now if you're working backwards, you have the hypotenuse. Hypotenuse equals the leg root 2. We only call it leg here, not short or long like we did for the 30, 60, 90, because they're actually the same length. The hypotenuse is 2 root 6. The leg is x, root 2. So we'll divide by root 2, and x is going to be, because they're both radicals, we can divide into each other, 2 square root 3. Here, notice that those two lengths are the same. So they're both 15 root 2. So the hypotenuse equals the leg times root 2. The hypotenuse is our unknown. The leg is 15 root 2 times root 2. So 15 root 2 times root 2. The radicals would multiply each other, give you the square root of 4, which is the value of 2. When you square square root, you get the value inside. So this comes out to be 30. On this one, we see a 45, 45, 90 triangle. If these two are the same length, then these are also 45, 45, 90. So that makes this 14. That makes this guy 14 root 2, because that's the hypotenuse of the 45, 45, 90. And to work backwards, that means you're going to divide by the square root of 2, which is going to come back down to 14. "30, 60, 90 rules. We'll use number 19 up here to help us with our formulas. Notice that we're given the long leg. This is the short leg. It's across from the 30. So the long leg is going to equal the short leg times root 3. So we're trying to calculate what the long leg is. The short leg is 7 root 3 times root 3. So this long leg, or x, is going to be 7 times, when you square square root, you get what's inside. So this x value is going to be 21. To calculate what the hypotenuse is, you multiply, let's see, I'll write it in here. Hypotenuse equals the short times 2. So we're looking for the hypotenuse. Well, it doesn't have a letter on it, but even if we were looking for the hypotenuse, it would be the short leg times 2, which the hypotenuse would. When you multiply these, you only multiply the terms that are the same. So this does not have a radical. You don't multiply it into the radicals. It's just 7 times 2, and then you bring along the root 13. For this problem, our long leg across from the 60 is 5. To figure out what the short leg is, we need to know the short leg if we're going to try to figure out the hypotenuse. You can't go straight to the hypotenuse from the long leg. So we're going to say the long leg equals the short leg times root 3. The long leg is 5. We'll divide by the square root of 3. So we have 5 divided by the square root of 3. Now I have to rationalize that denominator to get 5 root 3 over 3. So this short leg is 5 root 3 over 3. Now to figure out the hypotenuse equals the short times 2. This x is considered the hypotenuse. The short is 5 root 3 over 3, and we're timesing that by 2. Now a common mistake is to multiply too many numbers. You only multiply the top number, and only the number on the outside of the radical. If you multiply the top and the bottom, then we would get 10 over 6, which is reducible, right back down to 5 and 3. But if we multiply just the top, then we get 10, and the bottom is still 3. So this is 10 root 3 over 3. Remember, we're leaving our answers in radical form. That means it has a radical in it, no decimals allowed. So here we have a 30, 60, 90 triangle. The short leg is 31. To figure out the hypotenuse, it equals the short leg times 2. Well, the hypotenuse is x. The short leg is 31 times 2. So that's going to be 62. If the shortest side of a 30, 60, 90 triangle is 12, so let's make our picture. We have a 30, 60, 90 triangle. The short, it said, was 12. We know that the hypotenuse is 2 times that. The hypotenuse is the short times 2. So the hypotenuse is 12 times 2, which is 24. The long leg is going to be the short leg times root 3. The long leg equals the short, which is 12, times root 3. So it's simply putting a root 3 next to that 12 shows multiplication.